engine is the single heaviest component we put in an airplane. Installing the engine exactly as prescribed in the instruction is important to getting the CG right without adding a bunch of weight. The key part of that installation is figuring out how long the standoffs need to be to get the engine at exactly the right spot. In this video, we'll show you how to determine the length of those standoffs and some other things that are important to mounting an engine. The instruction manual provides the distance from the face of the prop washer to the firewall. I work hard at hitting this dimension exactly. Get this right, and the chances of having to add lead to the airplane when balancing it go way down. Most important on the engine is the distance from the prop washer to the back of the mounting flange. Subtract this dimension from the overall prop washer to firewall distance, and that gives you the dimension of the standoffs needed. You can determine the needed standoff length by setting the combination square to the overall prop washer to firewall distance. Hold the combination square against the prop washer face, and you can see how much of the scale extends beyond the mounting flange of the engine. And that tells you precisely the length of the standoffs needed. My QQ yak came from Flex Innovations with the firewall already drilled for the DA35. Often you'll have to use some kind of template to lay out where those holes go. Nearly all of the firewalls come with the crosshairs printed or engraved on them. Make sure you line the template with these crosshairs, not the center of the firewall. The location of the crosshairs compensates for the thrust angles built into the firewall. This crosshair also makes sure that your prop is going to wind up in the center of the cowl when the plane is done. Many standoffs will have one end that's wider than the other. That wider end goes up against the wood on the firewall. As you can see here, the firewall of the QQ yak from Flex Innovations has a fiberglass plate attached to it. Like a larger end on the standoffs, this helps prevent the standoffs from sinking into the wood and loosening up the bolt and changing the thrust angles. I have no idea why more manufacturers don't do this, other than that it costs more. I'm not using thread locker now because I'll have to take this motor off a couple more times before we're done. When I do install the motor the final time, everything gets blue Loctite. Here's a look at the inside of the firewall where I use the bigger washers to spread out the forces from the bolts so they don't collapse the wood. Now I can install the motor on the standoffs and snug everything down. We need the motor in place to determine where the linkage from the throttle servo is going to come through the firewall, as well as the fuel line. At this point I can better see where the manual push-pull rod for the choke is going to come to the front of the motor. With everything snug down, I can check the prop washer to firewall distance one more time to be sure that it exactly matches the specifications in the instructions. I have used standoffs in the past that were a little bit short and had to shim those out with washers. I would much rather have the right size standoffs to begin with. With the engine installed, I can start laying out things like the throttle linkage hole. I want to make sure the hole is located right and is big enough so there's no binding of the throttle linkage or anything else that comes through the firewall. Some airframes may not have the big hole in the center of the firewall, and that's for when this carburetor to firewall distance gets too short. With that hole there, it lets the carburetor breathe better. I don't even measure this anymore. If there's not a hole at the center of the crosshairs, I drill one, usually 1 inch and 7/8 in diameter. There's few things as bad as getting the plane all put together before you realize that the carburetor's starving for air. This is a good time to put the muffler on to make sure that there's no conflicts with the airframe itself. We also need to make sure that things like the fuel line and throttle linkages all clear the muffler as well. Now I can remove the motor and drill the holes where I've marked them on the firewall. I use woodworking brad point bits when I do this kind of drilling so it doesn't tear up the inside of the firewall nearly as much. Before putting the motor on again for the next round of fit-ups, I coat out the sides of the holes that I just drilled with CA. And I'm not bashful about flooding these holes with the CA because you want to protect this from the fuel and oil. I keep turning the fuselage 90 degrees and recoating the hole with the CA to make sure I seal up everything. If we let oil soak into that wood, we've got a lot bigger problem. I keep a length of fuel line with the plastic armor wrapped around it that I use when I'm checking the fit of fuel lines. I want to be sure that it comes through the firewall easily and that it gets to the fuel in it without kinking. Here I've installed the electronic ignition box. Now I can make sure that I have good options for restraining the cables so we don't have problems with them later. I also wrapped the plastic armor around the spark plug wire in a place where I can restrain it to make sure that that wire doesn't float around inside the cowl and rub on something and chafe it during flight. I know that I'll have to take the motor off at least one more time so I can Loctite all of the fasteners. Taking the time to mount the motor a couple of times so I can get everything fit just right saves us a lot of grief down the road.